Let's do factorization. What is a factor? A factor is a number that divides another number evenly. In other words, a factor is a divisor. For example, if we take 35, it can be divided by 5, it can also be divided by 7. So both 5 or 7 are factors of 35. Factorization is a process of writing or converting numbers or expressions in a product form. If they are in addition form or subtraction form, we convert them into product form. That's very useful in simplifying equations. For example, 98 can be written like this: 2 times 7 times 7. So 2 and 7 are factors, and it is written in a factorized form. Similarly, 3 plus 6x can be written like this. So here 3 is a factor and 1 plus 2x is a factor. Or x squared minus 3x. So x is a factor, or x minus 3 is a factor. If we have to factorize 210, how to factorize that? First of all, make a simple grid like this, and then think which number can divide 210. We always start with the minimum prime number, that is 2. If it can be divided by 2, we'll put 2 here. Yes. So 2 divides 210 into 105. Now can this be divided by 2? No. This can be divided now by 3. So we write 3 here, and 3 times 35. This 35 can't be divided by 3, so let's test it with 5. 5 times 7 is 35, and this 7 can be divided by 7. 7 times 1 is 7. So this 210 has been completely divided, and we are left with 1. Means this 210 equals 2 times 3 times 5 times 7. So this 2, 3, 5 and 7 are factors of 210. Similarly, we can factorize some other numbers. For example, 490. If we divide it, again the same grid, and we'll start to divide this by 2 and then by 5 and 7 and 7. So we can see this 490 has been factorized. Now factorizing polynomials. Polynomials is a vast topic, but here we'll just discussing factorizing polynomials and the easier ones, of course. Common factors. In polynomials where a common factor can easily be ascertained, it's easy to factorize. Let's see. For example, this one, 3x squared plus 6x. We can see that 3 is common in both of them, and x is also common in both of them. So we wrote 3x, and what was left? X was left in the first term and 2 was left in the second term. So we have two factors, 3x and x plus 2. These are factors of 3x squared plus 6x. Another example. Now there are 3 terms. In these 3 terms we can see what is common here. Yes, we can see 4, because 8, 24 and 12, all of them can be divided by 4. And the maximum of x can be taken out is x squared. So 4x squared is the common factor among all of them. Let's see what's left. In the first one, 2 is left. In the second one, 4 times 6 is 24, so 6 is left and m is left. And the third one, 4 times 3 is 12, and y is also left. So we have now 2 factors of this polynomial, which are 3 terms. So we have 2 factors. 4x squared is a factor, and 2 plus 6m minus 3y is a factor. Another example. Again we have a polynomial with 3 terms. These 3 terms are divided by signs of addition and subtraction. If we look in this example, we can see x plus 2 is common in all of these 3 terms. So let's take it out, but before that 2 is also common in the coefficients 12, 4x and 6y. We can take out 2, and we can take out x plus 2. What is left? In the first one we are left with 6, minus, in the second one we are left with 2x, in the third one we are left with 3y. So it has been factorized. We have converted this into 3 factors. Now we'll do polynomials, a little more difficult than the previous one, with the power of 2. Now here also we can divide them into 2 different types of polynomials. The first one, when the last term is positive, like this one, x squared plus 5x plus 6. The last term 6 here is with plus, that's positive. Or x squared minus 8x plus 15. Here also 15 is plus. How to do these type of polynomials? Let's see. X squared plus 5x plus 6. First of all, we have to break the middle term into 2 terms in such a manner that the sum of coefficient of the middle term and the product of is that of the last term. Let's see what does it mean. It means we have to think of 2 numbers. If we multiply them, we get 6, and if we add them, we get 5. So what are those 2 numbers? What can be those 2 numbers? 3 and 2. So this 5x in the original polynomial will be divided into 3x and 2x, like this. This x squared and 6 are as was there in the original polynomial, and this 5x has become 3x and 2x. So instead of 3 terms, now we have 4 terms. These 4 terms will make pairs of 2, the first 2 and the last 2. In the first 2, we can see x squared plus 3x, we have x common in both of them, and in the last one we have 2 common in both of them. So in the first one we took out x, what was left? X plus 3. In the second one we had 2 as a common factor, and we are again left with x plus 3. Here again we can see this x plus 3 is there in both of them, which can again be taken as a common factor, and we are left with x plus 2. So after these 2 steps, the original polynomial of x squared plus 5x plus 6 has been successfully factorized into x plus 3 and x plus 2. So this x squared plus 5x plus 6 equals x plus 3, x plus 2. Similarly, now we do another polynomial, x squared minus 8x plus 15. Again the middle term will be broken into 2 parts such that the product equals 15 and the sum equals 8. 5 and 3 can be those 2 numbers. So the middle term minus 8x will be divided into 5 and 3. So it becomes minus 5x minus 3x. If we add these 2, we will again be back to the original equation, original polynomial. Again we can divide them into 2 parts and see what is common factor. So in the first x squared minus 5x, there is x common factor. What is left? X minus 5. In the second one, 3x plus 15, 3 is the common factor. X minus 5 is again left. Now we have 2 terms in this polynomial, both of them have x minus 5, that can be taken out, and what's remaining? X minus 3. So this again has been factorized. So x squared minus 8x plus 15 has been factorized to x minus 5 and x minus 3. Let's do 3 more polynomials as a practice. You can stop this video and solve them, and then you can check. Okay, these are the answers. The first one is x plus 4 into x plus 3, second x minus 10 into x minus 3, third y plus 8, y plus 2. Now second case, here if you look, the last term is negative, minus 14 or minus 40. When this is the case, now we have to divide, we have to think of 2 numbers, which again whose product is 14, the last term, but here whose difference is 5. So when the last term is negative, we have to find out the difference for the middle term. So what can be those 2 numbers? 7 and 2. So we'll break the middle term into 7 and 2. Here if you note, the signs will be different. because we have to subtract them. So it's plus 7x minus 2x. We can have these four terms can be divided into two pairs. The first one has x as a common factor, the second one has minus 2. This x, if taken out, we are left with x plus 7. Similarly, if minus 2 is taken out, we are left with x plus 7. Now x plus 7 is common in these two terms. It can be taken out as this, like this, and we are left with x minus 2. So this has, again in these two steps, this x squared plus 5x minus 14 has been successfully factorized. Another one, y squared minus 3y minus 40. Think of two numbers whose product is 40 and whose difference is 3, 8 and 5. So the middle term is broken into minus 8y plus 5y, and which ultimately factorizes the original polynomial. These are 6 polynomials for your practice. You can do them and test your expertise. Okay, and these are the answers. Thank you for today.